In this brief video, we'll talk a little bit about how to execute some basic linear algebra commands in Octave. So the first thing we'll do is fire up the Octave GUI. Make sure you're not using the other Octave file. This is more of a graphic user interface, and it's prettier to work with, and it matches pretty much spot on what's happening within MATLAB. Of course, you can move these windows around if you'd like. If you prefer just to have the default setup, you can leave it alone. So the first thing that's important to do is to choose a directory that you're going to be working in, because that's where all of your files will be accessed. So my recommendation is to, on the gear, is to choose Set Browser Directory, and in here you'll either create a file or create a folder, and I've created one that I just called Octave Files for the sake of demonstration. So I'll choose that, and I'll just want to make sure that each time that I fire up Octave that I make sure that I'm in that directory. Otherwise, if your files don't appear here, that means that you're not going to be able to access them. So basic commands in Octave, or again, this same kind of thing applies for MATLAB, is I can do arithmetic on here. So if I want to do 5 plus 5, shows up as answer equals 10. And you'll notice that I have the command history here in case I don't want to have to type something in again. Then I can just double click and it will execute that command. So every time you execute something in the command window, which is the window that I'm in right now, and press enter, you'll see over here in the workspace a variable is defined, and the variable's name is ANS. So you can never create a variable called ANS. ANS is reserved for the most recent answer. So basically right now you see that 5 plus 5 is 10, and its data type is called a double, and double is a fairly works with fairly large numbers. It tells me that its dimension is 1 by 1, and same thing with MATLAB. It works in terms of matrices, and then it tells me what it's valued at. So I can also assign numbers or arithmetic sequences to variables, and I just type in x equals 5 plus 5, for example. And when I click enter, it tells me that x equals 10, and over here it creates a new variable whose name is x, again, of class double. It's a 1 by 1 scalar, and the value stored in that scalar is 1. So now I can do operations. Now, if I try to do 2x, really what I'm trying to do is 2 times x, it's going to throw a syntax error. MATLAB and Octave are very specific, so you want to do 2 times x. There's no implied multiplication. And you can see that right away the answer is 20. Now, if I want to create a variable that stores the value of 2 times x so that I don't have to mess with the variable x, maybe I want to use that again sometimes. Well, now I created a new variable, again, double 1 by 1, and now its value is 20. It's equal to 2 times x. I can also do things like reassign values of x. So maybe I want x to equal x plus 10. So that's going to take my most recent x value, which is 10, or maybe we'll do 30 just to demonstrate that x will now become 40. So I can also reference the variable within the variable definition. Now, to create matrices and vectors, now anytime you want to clear out what's in your workspace, because this can get convoluted, and you type in clear, that will clear out your workspace. So now those variables x it's going to throw an error if you try to call those. It says these variables are undefined. You can also type in CLC, that's for clear screen, and that'll clear out your command window, make it nice and pretty. You can also do clear window by right-clicking, and so what we're going to do first is define a vector. A vector is a very similar type of process. I can call this vector x, and I'm going to use a square bracket. And in the square bracket, if I type in a sequence of numbers and I separate them by space or by comma, then it will create a vector. And now you see that over here, x is of class double. It's a 1 by 3, so it's a 1 by 3 vector, and it stores the value of 1, 2, 3. Well, you might say, well, I really don't want a 1 by 3, I wanted a 3 by 1. So the way to do that is of a similar format, except instead of putting spaces between the 1, 2, and 3, I'll put a semicolon between them. And that will, now you notice in the workspace, it creates a 3 by 1, and it displays as a 3 by 1. Also, if you want to create a 1 by 3, you can use commas, and so that's the same thing as doing what we did up here. You notice creates the horizontal vector 1, 2, 3. Now, if I want to transpose the vector, if I want to create a column out of a row vector, then what I can do is I can type in transpose of x, And I think I might have this backwards here. I don't think I want to use capital. So if you're calling commands, you're going to notice that it's very case sensitive. So capital transpose and lowercase transpose are not the same thing. It's telling me that it can't figure out what I'm trying to do here. So lowercase commands work for the most part. Now you'll notice that now x has become a 3x1 by way of transpose. If I create another vector, and I'll just go ahead and say I create another vector that's 4, 5, 6. Now this is a row vector, it's a 1 by 3, and if I attempt to add x and y together, it's going to do something really bizarre. And you can probably try to figure out what it did, but it certainly didn't add vectors the way we want vectors added, and that's because I tried to add a 3x1 to a 1 by 3. So the plus command is very strange in how it works. We won't talk about that here, but if I want to add two vectors together, I've got to make sure they're of the same dimension. So, well, y I defined as a row vector, and so what I want to do is I want to transpose it. I want to reassign y to the transpose of y, and now when I add x plus y together, you'll notice that it gives me the desired result, 5, 7, 9. And if I want to store that to a new variable called z, I can say z equals x plus y, and I come up with a new vector that way. So fairly intuitive to work with, and maybe if I want to take a linear combination of those, I can say z equals 2 times x plus 4 times y, and it does it very optimally. So defining vectors is fairly straightforward, working with them is fairly straightforward, and a lot of commands you can find in the documentation. So depending on what you want to do exactly, you can come over to linear algebra and you can say, basic matrix functions, for example, and there's a lot of documentation here. It's kind of hard to get used to. It looks overwhelming, but this is a place where you can kind of go and learn more. And if you want to do something specific, you can always use Google. Last part of this video that I want to talk about is the editor. And in the editor, if you want to keep track of everything that you're doing in your command window, well, first of all, it gets very convoluted very quickly. Also, one of the things you can do is if you don't want to show the result of an operation, like you want z to equal 3 times x plus 4 times y, but you don't want Octave to show you the result like it did in this previous step, then if you put a semicolon at the end, it will basically terminate printing to screen, and it will still assign the value of z. You notice that 19, 26, 33 should be what we get if we take 3 times x and add 4 times y to it. So that's a little trick. Semicolons at the end of a statement will prevent anything from being printed. In the editor, if I know I'm going to do a bunch of stuff, or I want to keep track of what I'm doing, the editor is a great place to do that. So I can do things like define my code in here. So I want to create a vector that's going to be a column vector 1, 2, 3. And again, I want to display that, so I'll put a semicolon. Y equals, we'll say 4, 5, 6. Close out the semicolon. And notice that nothing's happening over here. In fact, if I come back to my command window and I type in CLC, and I go to my editor, and now I type in z equals x plus y, semicolon, I press enter, nothing happens. It's just creating new lines. This is what we call a script. And a script is much like a script in a movie. It just is just documenting everything that we're going to ask Octave to execute, or MATLAB if we're using MATLAB. Now we can go ahead and execute all of these, and the way you do that is you can click the save file and run to the play button, and the first thing it's going to ask you to do is to save the file. It won't execute it until you've saved it, and you can always tell if a file has been saved. 1, if it says unnamed, and 2, if you get the little star here, that means there's been updates made since the last time it was saved. So I'm just going to call this linear, I'll call this fun test, and now I'll click save. And the cool thing is you can also open this up in MATLAB, or you can create a file in MATLAB and open it up in Octave as long as the commands are the same. Okay, so now what I can do is I can basically come over here and just press the play button. And now if I go to my command window, it just told me that it ran fun test. And you can see that the variables have been created. X has been created, Y has been created, and then X plus Y has been created through that single run. So now if I want to come back and I want to modify something, I can say, oh, I really meant this 4 to be a 7. Now, again, you'll see the star show up here. If I press save file and run, it won't ask me to save the name of it again because it's already been saved as funtest.m, and you can see that the z vector has been updated. Very important, convenient thing to do so that you can go back and you can always access, how did I come up with this information? Finally, if you close out of this, And you can always create a new file or a new script. We'll talk more about new function later, but all this does is this creates a bunch of default coding and stuff like that, and it's very confusing. So we don't really want to mess with that right now. So you can always create a new script if you want to basically do a different problem in here. Finally, if you want to come back and you want to run fun test, but you don't want to open it, then you can actually just type in fun test. So let me clear my screen and clear the command window or the workspace, and I'll run fun test, and you can see again that all these things have been created. Nothing has been printed to the screen because I haven't asked it to print. I put semicolons at the end of all the things in the script. If I want to see, okay, well, wait a minute, what did fun test, what code does that have? I can double click on it, and I'm not sure why that's not showing up here. There it is. So if I go to editor and I double click on that, then fun test will open up again, and I can see what's inside of there. So that's where we'll go ahead and stop. That's how you can do some basic commands in Octave. And of course, we can also import data vectors from source files, but we won't do that in this video. So that's it, and I hope this has been helpful.